Hey all, so I got this question on in the support thread, and after reading it I thought that this question might be of such a general interest that perhaps I should make a video about how I'm solving it. Similar questions have been asked several times before in earlier versions, but since I just made a new version of the toolkit, I felt it was a good opportunity to go into it. The question is from Munchido1, and it goes as follows. Is it possible to make the tile costs come from the unit rather than from the tile itself? For example, I would want one unit to be able to traverse water tiles freely, while another unit would have a movement penalty on the same terrain. My original idea was to have a struct of integers representing the cost of each kind of terrain within the unit blueprint and an enum for the terrain type of each tile, forest, water, etc. In the tile blueprint. Then I would be selecting the cost based on the tile's enum from the values in the unit struct within the pathfinding blueprint. This approach ended up not working though, and I'm not sure if I was just missing something silly. Now this is pretty close actually to what I would personally do, but the devil's in the details, of course. So in explaining this, I think I will be able to get into quite a few things like pathfinding and how to modify the grid manager to have new sorts of data stored within the tiles within the grid, and how to manipulate and use that data. Okay, so let's get started. Here we are in the standard example map. I've just kept two of the units here. So we want to have one of these units, as requested, able to be walking on water tiles, and the other one should be able to walk on other tiles as well and have a reduced movement when walking on water tiles. So we need some way to represent the different kinds of tiles on the grid. So first we want to create an enum, and I'm just going to, for simplicity's sake, just create all of it here in the main content folder while we're working on this example. So first then let's create an enum for the terrain type, so I'm calling it eTerrain, starting with an E as per the Unreal Engine convention for naming enums. And then we'll have a few types of terrain, so we can have, say, dirt, and we can have then water, and let's say forest. So 3 types. And then we want some sort of tile that we can place that will tell the grid what type of terrain it's on each tile. So we can then create a blueprint. We can base this then on the grid actor. So the grid actor is a blueprint which holds some code for finding the grid index of the tile it is placed on. So we'll call this BP and GA for grid actor, and then I'll call it terrain. And let's get into this blueprint. So we want to then have an enum variable that holds the type of terrain that is in this actor. So I'll call it terrain type, and we'll have this be our new terrain variable, and we'll make this instance editable so we can edit it when we place it in the level if we want to. And then we will want to visualize this in some way, so I will add a static mesh here. I will connect this to the grid anchor so that it will snap to the grid. I will use the let's see, hexagonal shape, since we are on a hex grid here. And the material I'm going to set based on the type of terrain. So I can do this in the construction script. So let's go to the construction script here, and then we find the terrain type. We're gonna do a switch on the terrain type, and then for the static mesh, I'm going to set the material. Actually, let's not use a switch of this kind. we'll use a select node instead, just a tiny bit cleaner. And then based on the terrain type, we're going to set the material. So if it's dirt, we're going to set this to brown. If it's water, we're going to set this to blue. And if it's forest, we're going to set it to green. There. Let's see how that looks. If we place this terrain tile, we can see that it is dirt by default. And when we change it, we get a different color. Let's see the forest here. Is my shader still compiling or something? I guess it is. There we are, nice and green. Okay, so we have our tiles. We are storing the type of terrain that are in them. So let's first create just a little forest. We can place that here. And then we'll have some dirt tiles. Let's just place a bunch of tiles first, and then I can select the ones I want to. So doing this with tiles might not be the best way to do it. If you have, small levels and they're handcrafted and so on, then that will be fine. But for your game, you might want to have some sort of procedural system or whatever to create the tiles, but we're doing it simple here. So let's select some of these tiles and turn them into water tiles. And these tiles here I'll turn into dirt tiles. And we'll place our little boat, which is this guy, on the water, and this guy outside of the water. At the moment, of course, it does nothing. They just move as normal, so we're gonna need to have this affect pathfinding in some way. First step, we want to make our grid manager aware of these tiles. So I'm going to have some way to represent these tiles within the grid. So I'm going to edit the grid manager. Now I'm going into the hex tile. I'll edit the base grid manager in this case. For your game, you might want to do this through a component or something, but yeah. But actually, yeah, modifying the grid manager itself is fine. So then I'll add a variable, and I will call this grid terrain. As you will see in the grid arrays here, anything that I have that where any map variable where the index or the key is representing a index, which is the tile on the grid, I start with the name grid. So I do the same here. So then I create a map, and I have an integer as the key, which is the grid index, and then I will have the terrain enum as the value. So I could populate this in the grid manager itself during setup by going through each of these tiles and adding them, or I can have the tiles actually do it themselves. I'm going to do this approach in this case. So on begin play, I'm going to get the grid manager, and since this is a grid actor, we have a reference here. If you don't have a reference, you could also use this get grid manager singleton. It's slightly less performant, but it works anywhere. So I get the grid manager. I find then our new grid terrain map variable, and to this map variable I'm going to add the terrain. So add, and the index will be the grid index of this grid actor. We can't see it because we need to show the inherited variables, but here it is, grid index. And the terrain type, we're using our terrain type variable. Okay, good. So now these are all added to the grid, but it would be nice to be able to check that. So just to be able to debug this quickly, I'm going to go to the event graph here of the grid manager. I'm just going to take an event that if you press the X key, I'm going to find the tile that the mouse is hovering over. So it's the get hit tile and location and index. Then I'm going to find grid terrain, find the grid index that is under the mouse. If it is a valid tile, I'm going to print of the terrain. And if it's not, I'm going to print no terrain. So if we hit play and try this out, see. So if I hover over this tile here and press X, you can see text is a bit small, but on the top left here it's water, and if I go here it's forest, here it's dirt, and here it's no terrain. Excellent. Okay, should probably delete this so we don't keep it in our game by accident, but yeah, we're just doing a tutorial now, so I'll keep it here. So okay, fine, we have our terrain, we have our tiles, we can place them, they are added to the grid. So this is a way you can store whatever data you want in the grid. You can have this way, you can create new types of map variables. You'll have the key always be an integer, and then the value can be whatever you want. It can even be, you know, arrays of objects or anything you want to. So this is a simple way to add data to tiles for whatever custom purpose you have for your game. But yeah, so we want to use this terrain now, and as you recall from the original question, we want to be able to define within our individual units how they move on different types of terrain. So let's do that now. Again, for simplicity, I'm going to modify BP unit directly. You can do this, of course. I mean, if in your game all units are supposed to have the be able to define how they move on different types of terrain, it might make sense to modify unit directly, but perhaps you prefer to keep things modular and add this as a component and have the variable be in there. But yeah, we're doing it simple. So in BP unit I will be adding a new variable, and this will be then, I'll call it TerrainCosts, and this will also be a map. Yeah, you can select map it if it's a boolean, so I'll just switch it up. So we want to have then the terrain as the key, and then we want to have the value here as the cost, which can be an integer, because that's movement costs are defined as integers in this toolkit. So we'll have this, and we'll have it be instance editable. And we can add some defaults here if we want to. We can have that by default. We want to have a movement cost of 1 on dirt, and oh yeah, that's a problem with using maps in this way. When we're adding, we're just trying automatically to add the first default option, which is dirt, and that can't be added because you can't have two of the same key. So we'll have to start with some of the other ones there, and then we'll add dirt last. So on forest we want to have a movement cost of 2. On water we'll place that 0, and we'll let that represent not being able to move onto it, and dirt is 1, and this will be our default. And for this guy outside here, or actually, come to think of it, I think in the request he wanted to be able to move on water but just slower, so we'll have water have a large movement cost by default. So we'll have this for this guy, and then for our boat here we're gonna have it different. He can move on water just fine, but he's not able to move on then forest or dirt. Actually, we'll still be able to move out of the water here, so let's just surround this little pond real quick with water. Oops, what did I do? There we are. Okay, fine. So we have our boat guy, we have our non-boat guy who can swim, and then we need to have their pathfinding actually make use of this new terrain information that we have added to our grid. So to do that, we're going to need to add a new pathfinding type. So I'll select a new blueprint class here, and I'll search for BP path. And that's the one we need. So this will be a child of BP path, so we'll call this BP path and then terrain. Let's enter this. We don't have anything to modify here. We want to override the functions. So this is the main one we want to modify. Add tile if valid. I described this briefly also in the 3.0 overview video, but to explain it again, when pathfinding is running, path terrain, do we have a compiler? Yeah, of course, I just added it here. Yeah, let's delete this temporarily so we can play. So when pathfinding is run, we start at this index here, and then pathfinding adds all of the tiles that are connected to this tile. And each time it tries to add a tile, it looks at this function that we looked at here, add tile if valid. And this can be defined in any number of ways. Like in the default pathfinding, it's pretty simple. It's like, do we have enough move left to be able to move into this tile, considering the cost of moving onto that tile, using the regular edge costs. And is there any unit on it? If it's a unit on it, then we cannot move on to it, and so on. But we want to have some additional rules. We want to keep those rules as well. Let's see, there's path terrain. So we want to keep those. So we want to make sure that we still have our that we're calling the function here on the parent, but we want to modify the movement cost of entering this tile. And we can do that before we run the parent function here. So we need to get, we have the grid manager reference here, luckily, so we can get our grid terrain, and we can find the terrain of the tile that we are entering. So the edge index, that is the grid index of the tile that we are attempting, the pathfinding is attempting to enter. And we see, check here, can we find, is this tile on the terrain? And we can say, we can say that if it's not, we're actually not adding it. We only want to move on things that are on our, that are defined in grid terrain. But we can also say if there's no terrain defined here, we're going to run pathfinding as usual. So I'm going to do this now. But if there is terrain on this tile, we want to modify the cost of entering this tile based on this terrain costs map variable that we have within our units. So there are many ways we can do this, but something we want to keep in mind is that to not add too much stuff within this add tile is if valid function, because if you recall that this function is called every time a tile checks during pathfinding if it can enter a neighboring tile, and then this tile checks and it checks back and it checks all of the other tiles surrounding it. So this is called a lot, and the toolkit can handle this just fine because I've designed the pathfinding functions to be very efficient in what they are checking. But if we start adding lots and lots of stuff within this add tile if valid part of this function, then it can get very expensive very quickly. So we want to avoid that. So if we can, we want to front load our computations, and we can do that by overriding the run pathfinding function, which is the start of our function here, and we can try to get as much information as we want beforehand. So first here we want to find our unit so we can get the appropriate pathfinding costs from that unit. So we have the start index of the pathfinding, and this gives us the index at which the unit is starting on. Note that in some cases you might be using your pathfinding functions for other things where you're running pathfinding where the origin is not a unit and so on, so then you need to be mindful of that if you're doing something like that for your game. But if you're not, if every time you're using this custom pathfinding it is because there's a unit that's trying to move, which will generally be the case, then this approach shall be just fine. So we can get our grid manager ref, which we have a reference to here, and we can then get our grid units, which has all of our units on it, and we can find the unit that is on the start index. Yeah, and if you didn't know already, any variable that is in a function as an input, you can use it as a local variable. It is added automatically. Just handy for organization. So first we want to check that there's actually a unit on this tile. If not, then we're going to just return here without a path and return false. Let's see, I might get an error. No, that's fine. If there is a unit, we want to continue, but we want to find out the terrain costs of this unit. So we get the terrain costs. We could store the unit, and we could within this function we could query the unit for these terrain costs every time. But remember, we want to do as little as possible here. And for blueprints, actually every node that you're calling does have a small inherent cost, which is different from what you might be used to in some other programming languages. So we're going to promote this as a variable, and we're going to call it, yeah, we'll just keep the name, why not? And now we have access to the terrain costs of this unit. We want to plug in all of these standard pins here so that it's still working, and then we can now modify. Now let's see, I can't parse the default enumerator. That is odd. Did we forget to save everything here or something? Let's just try to save everything and also fix up the redirects. It shouldn't matter, but yeah, we still can't parse it. Let's see the train costs here. If I just add a variable, okay, then it's happy with it. Yeah, so that's just a warning, so it will run no matter what. We want to avoid as many warnings as we can. So we'll keep a default here, but it's going to be overridden every time, no matter what. So that won't actually make a difference. But okay, so we have access to the terrain costs, and we can get this here. So we try then to find if we are trying to enter a tile with terrain. Okay, then we want to check our terrain costs. Remember, this comes from the unit, and then we find the cost that this terrain has for this particular unit. In this case, if the unit does not have a defined cost for this terrain, I'm going to treat it as if it cannot move on this terrain in this case. So if we can't find the cost for the terrain here, we're just going to return out without running this parent function. And this parent function, I can go into this and show, it's what adds the tiles to the paths and to this open list of tiles that are checked during pathfinding. So if we don't run this, then this tile will not be added for consideration in pathfinding. So we're just breaking out, and this tile is not added. Now, if we can find the terrain cost, then we want to continue, but we want to modify the total cost of entering this tile. But wait a second, if it had a cost of 0, then we also wanted actually to break out. So we're going to check this as well. But yeah, no, actually now that we have defined it this way, then we'll just leave out any terrain that we don't want to be able to enter, and then we'll avoid having an extra check. It might make the code slightly less readable, but remember, we want to have as little as possible called within this function here. So we'll keep it as this, and then so if it's true, then we will add this cost to the total cost of entering the tile, and that will be the total cost of entering. Great. Having done that, I think we will need to modify these costs slightly, because now we're actually adding the costs here. So for this one, we want to then just delete dirt and this, and we'll have water as 0. That means that it's 0 added cost, the way that we made this now. And for this guy, we want to have an added cost of 1 for forest, 2 for water, and for dirt we want to have no added cost. Now lastly, we need to make sure that these units are actually using our new kind of pathfinding. So let's select both of these units. We will find their, let's see, is it movement options? Yeah, that's the one. We will find our new terrain pathfinding type and set that as their pathfinding. Okay, let's see if it's working, and I haven't recorded all of this in vain. Yeah, here we see, yeah, he can't actually move at all. And this guy can't move either. Well, that's disconcerting. Let's check our message log, because we have some warnings. And live debugging, exciting. Okay, so we're accessing none, trying to read the grid manager within the path train. Ah, that makes sense. Okay, so I know what's going on. Let's hope it works this time. So I'm going to path train. Yeah, I clicked the error, so I got directly to where the error is happening, which is here. And this is because there's no reference to the grid manager. And why is this? Well, that's because this grid manager ref is actually set as path as part of this parent blueprint here. You can see at the very start it is set, and since we're doing all of this before we're running this, then we don't actually have access to this variable. We can't simply just place this beforehand either, because this is the part of the function that calls all of the stuff where we want to access our new TerrainCosts. But we have the input directly here, so no problem. We just plug this in instead, and now it should work. Let's see. Yeah, okay. So I can move. This guy can move normally, and yeah, if we're trying to move through the forest, you can see that he will try to move around it. He can move through it, but it slows down his movement. Same for moving into ocean tiles. And if we select this guy, he can move in his little pond, but he can't move outside of it. Fantastic. Okay, so that was it. I hope that answers your question to your satisfaction, what to do. And I hope it was also useful to others to see some ways in which you can modify the toolkit to add your own like custom data to tiles, modify pathfinding, and so on. So yeah, let me know if you find these sorts of like quick experiments and playing around with the toolkit useful. I'm also going to, of course, make these more thorough videos where I go through the different features and explain the reasoning and so on, but this is more off the top of my head, where we're trying stuff out and showing ways in which you can add new features to the toolkit. So yeah, let me know if you think that's useful, and thanks for now.